In this video, we will discuss about top 5 basic computer comparison. First, what is the difference between algorithm and flowchart? Algorithm is the step-by-step process. Flowchart is presented in a pictorial form. In an algorithm, it is easy to debug errors. Flowchart errors are hard to debug. To create an algorithm, there is no hard and fast rule. You should have some rules to create flowchart. Algorithms are hard to build. Flowcharts are easy to create. Algorithm process is less time-consuming. Flowchart take more time. Algorithm uses plain text to write algorithm. Flowcharts uses symbols or shapes. In algorithm, you can see the solution in a language like English. Flowcharts are used to illustrate the solution. Second, what is the difference between compiler and interpreter? A compiler translates the complete source code at once. Using an interpreter, we can translate the source code line by line. Show all compilation errors at once in compiler. In interpreter, display the errors on each line one by one. The compiler code is difficult to debug. Interpreter code is easy to debug. In compiler, separate files store object code. Interpreter does not save the object code. Compiler is faster and more efficient for converting source code to machine-level code. The conversion of source code to low-level machine code is slower in interpreter. There is a static allocation of memory in a compiler. The memory allocation of an interpreter is dynamic. In compiler, there is a greater use of CPU. In interpreter, CPU utilization is less as compared to compiler. Compiler takes less time to execute as compared to an interpreter. Interpreter takes more time to execute as compared to compiler. During the process of translating source code into object code, it is not possible to view the compilation results. As the interpreter translates lines one by one, the results are visible during translation. There are many programming languages that support compilation, such as C, C++, Java, and C#. Some programming languages support interpreters, such as PHP, Ruby, .NET, Python, Perl, BASIC, etc. The compilation process creates intermediate-level code. Interpreter does not contain intermediate-level code. Third, what is the difference between input and output device? Input device accepts data from user. Output device reflects processed data to user. Input devices are controlled by the user. Output devices are controlled by the computer. Input device converts user-friendly instruction into machine-friendly. Output device converts machine's instructions to user-intelligible. The design of input devices are more complex. The design of output devices are less complex. The devices which are used to give input to the computer is called input devices. The devices which are used to display the output is called output devices. Input device takes the data from the user and sends it to the processor for execution. Output device takes the processed data from the processor and sends it back to the user. Input device example: mouse, scanner, microphone, touch screen, OMR. Output device example: speaker, printer, projector, monitor, plotter. Fourth, what is the difference between RAM and ROM? RAM stands for random access memory. ROM stands for read-only memory. RAM is a volatile memory, which means it stores data as long as power is on. ROM is non-volatile memory, that means it stores data permanently even when power is off. RAM memory is large and high capacity. ROM is generally small and of low capacity. Data in RAM can be modified, erased, or read. Data in ROM can only be read, it cannot be modified or erased. RAM is used to store data that CPU needs for current instruction processing. ROM is used to store data that is needed to bootstrap the computer. RAM is used as CPU, primary memory. ROM is used as firmware by microcontrollers. The stored data is easy to access. The stored data is not easy to access as it is in ROM. RAM is expensive when compared to ROM. ROM is cheaper when compared to RAM. RAM is a temporary storage. ROM is permanent storage. Writing data on RAM is faster than ROM. Writing data on ROM is slower. Fifth, what is the difference between hardware and software? Hardware is tangible. Software is intangible. Hardware is a physical part of the computer. Software is a set of instructions that tells a computer exactly what to do. Hardware is repair in case of problem. Software is debugged in case of problem. Hardware can be touched. Software cannot be touched. Hardware example: keyboard, RAM, ROM, printer, mouse, hard disk, etc. Software example: MS Word, MS Excel, MS PowerPoint, MySQL, Photoshop, etc. Hardware is not affected by computer viruses. Software is affected by computer viruses. If hardware gets damaged, it is replaced with new one. If software get damaged, it is reinstalled. Hardware has four main categories: 1. Output devices, 2. Input devices, 3. Storage devices, 4. Internal components. Software is mainly divided into 2, 1. System software and 2. Application software. Hardware is made of electronic components like ICs, registers, diodes, insulators, etc. Software is made of codes in programming languages, alphabets, numbers or alphanumeric symbols, etc. A hardware can be only physically transferred. Software can be transferred electronically. Hardware cannot perform any tasks without software. The software cannot be executed without hardware. Hardware understand only machine language or binary language. Software can develop in machine language or assembly language or high-level language.